About 20 years ago, a colleague and I had a debate as to whether Linux could have malware in it. He said no, I said yes. Turns out I was right. It turns out, in fact, any system, if it's operational, can be broken into. It can be hacked. It can have malware. So it shouldn't come as a huge surprise. But that's not to say that open source isn't secure. In fact, it can be very secure. But let's take a look at what are some of the considerations. I'm going to take a look at open source security in this video, some of the things that we should be thinking about, and then ultimately conclude with some guidance so that you can make sure your open source projects are in fact secure. Let's start with some definitions. First of all, what do I mean by open source? Well, to talk about this, let's first talk about proprietary. Proprietary is a system that's closed. I can't see what's in it. If we're talking about software, I don't see the source code. I just see the executable version. So it's a black box to me. An open source project, open source software, in these cases, I can see inside the box. I can see how it works. I can see if it's an operating system, well, I can see the source code. If it's an application, again, I can see the source code. If it's going to be an AI model, I can see the source code. And yes, AI is another example of something where we're going to be using open source models. And then one of the classics is with cryptography. So in this case, what I want to be able to do is see how the crypto system works. That leads us to our first point, Kerckhoffs's principle. Kerckhoff had this idea that a crypto system should be secure even if everything except the key is public knowledge. So Kerckhoff was telling us that basically, if I have plain text that I'm going to encrypt, I'm going to put that into my encryption system, and then what comes out is going to be a bunch of gobbledygook that no one can understand. This is the ciphertext, plain text, ciphertext. And the only thing that should be a secret about this system is the key, this thing right here. That key, as it changes, will change this plain text into a different ciphertext. That's it. There should be no secrets in this. This should be publicly known. And why is that? Because the more people that know it, the more review we can do and the more problems we can tease out of the system before we put it into production. And that's, in fact, how the rules that we have followed when it comes to cryptography these days. Now, the contrary to that is this notion of obscurity, in particular, security by obscurity. And you know what security by obscurity is because you've seen examples of this. Imagine at your home, you've got a key to the door. Now we're not talking crypto keys, we're talking physical keys. You've got a key to get you into the front door. And where do you hide that so that nobody could ever figure out where it is? Well, right here under the welcome mat. No one's ever going to think of that, right? Well, of course, that's the idea of security by obscurity. I can't see the key because it's under the mat, so therefore it's secure. Yeah, it's not so secure because the problem is secrecy doesn't end up being a very good way to ensure security because secrets ultimately become known. Let's take a look at the thousand eyes principle. This basically says that if I have enough people all inspecting open source code, that they are going to find the vulnerability. And the idea is really sound. The principle works. However, think about looking at a complex system. In the case of Linux, there's on the order of 27 million lines of code. That's a lot of stuff. And I'm going to find the vulnerability that's right there. Okay, even with 1,000 eyes looking at 27 million lines of code, that's a problem of scale. Are we going to be able to scale the inspection of individuals in order to find all of the vulnerabilities? And who ultimately feels responsible to do this? A lot of people use open source, but not everyone contributes to open source, and not everyone is looking for vulnerabilities in open source. So it's a subset of that community that actually is trained and understands what to be looking for in the first place and feels a personal responsibility to go off and do that level of inspection. And then support. If we do find, who is going to fix it? Who's going to verify that the fix that somebody wants to suggest, okay, we have processes for doing all of this, but the point is, it's not as simple as just saying, we put it out there and the community finds all the problems and everything works perfectly. It doesn't. Now, having said that, we've had some big successes. So this general principle does in fact work, and I'll give you some examples. two really classic ones, and I just mentioned one of them, is Linux operating system. Very solid operating system. And it has the ability that you can configure it to be very secure. It's withstood the test of time for decades, about 3 decades now. And again, very solid operating system. We can do some great stuff with this. Another example, borrowing from the world of cryptography, the standard that we all use for symmetric cryptography these days is called the Advanced Encryption Standard, AES. And it was developed in an open source model. In other words, the algorithms were submitted, everyone had an opportunity to look at the algorithms and understand how they work and try to figure out if there's a way that they could break them. And so far, no one has found a way to break AES that's anything faster than brute force. So that's a success. Now, so we've had some of those, but how about some of these? Well, we've had some of those as well. One of the most notable is a vulnerability to a component called log4j, which is open source software that was included. It's logging software that logs activities included as part of Apache, and it was included in tons and tons of products, in tons of projects that people worked on individually and in large groups. And we found a few years ago that there was a vulnerability, a very serious vulnerability in this. Even though it had been available for people to review for years, there was a serious vulnerability that gave an attacker potentially complete control over the system. So in that case, the Thousand Eyes didn't find the problem. And ultimately we found it, and now there's a fix. But not everything gets caught, is the point. Some other things that we found, IDC reported in 2023 that there was a 241% increase in software supply chain vulnerabilities. That's a big number. Looking at open source and saying we're using all of this code and that the number of vulnerabilities is increasing astronomically. And they went further on to say that it affected roughly 64% of organizations. So it's not like just a few people are getting hit by this. It's affecting lots and lots of people. So as software grows, as these open source projects grow, we're needing to grow our responsibility, our support, our skill level, and our ability to really analyze all of these things effectively. Now, another bit of information that we had from one report was a problem is that coders will sometimes encode secrets directly into their source code. What kind of secrets do I mean? I'm talking about passwords, I'm talking about crypto keys and things like that. They found that in analyzing code that there were 4,000 secrets embedded directly into source code. That's a lot. And because it's source code means anyone could look at it and see what it was, and therefore anyone could take advantage of it. And those 4,000 secrets, unique secrets, embedded in open source code affected 450,000 projects. These, again, are alarming numbers. So we shouldn't be doing that, but it's not like just a few people did it. It happened on at least 4,000 occasions that this occurred. So we've got to do a better job. We have our successes, but we also have some failures. Okay, what can we do to avoid some of the failures that I just mentioned? It turns out there is some good guidance out there and resources you can take advantage of. There's a group called the Open Software Security Foundation, OSSF. Their website, you can see, ossf.org, includes a lot of good educational materials. So you can learn more about what you need to do to make this stuff not fail. In addition, they have some guides. In particular, they focus on open source development, what are secure coding practices and things like that that you should follow, project management and project considerations for running an open source project, and also industry best practices, the things that we've learned that are the time-tested principles that we know work and help us avoid that and achieve more of that. So what about that debate? Is open source more secure or not? I'm going to say it's not more secure, it's more securable. And that's what makes the difference. In other words, I have the ability to leverage the Thousand Eyes. I have the ability to leverage Kirchhoff's principle and not rely on security by obscurity so that I can achieve these successes. So open source can be more securable, and that is the goal that we're ultimately after.